So in this section, we will summarize our approach to designing a database in a greenfield microservices situation, basically where you don't have a database and you need to start a database from scratch for your microservices architecture, a database that belongs to a microservice. The first idea is to use function first design, i.e. define your microservice first using techniques like the bounded context, and then once you've defined your microservice, as part of the bounded context, you'll define the models which will become your database, and then on top of that you can use code first tools to actually implement your database from those models. And the other key takeaway from function first design is that we avoid modeling the data first. Model the microservice first using bounded context, and that will automatically define the models that form your database. And where we can, we also want to avoid anemic CRUD-based microservices, where all they do is take the internal database and then make it available through a service by presenting all the internal models as resource endpoints, where you can update, retrieve and delete the data in the database directly using the database models. We want to separate the internal database models from the external contract models which form the functions and the contract of our microservice. We basically don't want the future changes to the internal workings of our microservice affect its external contract, because this will break the client applications. We also want to avoid a situation where our microservice's main function is hindered by loads of read requests, so that other services and applications can get to that service's data, i.e. share its data. And instead we should rely on events, where we raise events when we want to share data with the rest of the system. And we should also think about how we store those events. And one recommended design pattern is the event sourcing design pattern, which shows you how you can store the events so that the events can be replayed and rebroadcasted to the system when required. If sharing data using events doesn't fit your scenario, so for example, let's say there are applications or services within your system which require data from your service in bulk, so data from your microservices microdatabase in bulk, you might choose to split your microservice into two microservices, where one is responsible for receiving the events, receiving the updates, i.e. the commands, and the other one is responsible for sharing the data, i.e. satisfying queries. And this way, the need to share data with other services and other applications in your system doesn't hinder the write performance or the main function of your microservice, because you split the reading out into a separate service. Now that we've summarized our approach to creating greenfield microdatabases for our microservices, in the next section we will look at a stepped approach in taking a monolithic database and then splitting that up into microdatabases.